Good morning, students. I am Professor Prakash Rokde. Today we will learn Software Designing and Model Unit number 3, Interaction and Behavioral Modeling. In it, the very first diagram is the activity diagram. Activity diagram describes the dynamic aspect of the system. It is basically a flowchart to represent the flow from one activity to another activity. The activity can be described as an operation of the system. The control flow is drawn from one operation to another. This flow can be sequential, branch, or concurrent. Activity diagram deals with all types of flow control by using different elements such as fork, join, etc. This activity diagram is used to develop the executable system by using forward and reverse engineering techniques. In this diagram, the messages are passed between one activity to another activity. Now see, this is the diagram for activity. You can see here, initially here is the start. You can see here the start. It is a precondition. Then control flow by arrow, it is called as action input. Then actual activity in step 1, this is the system step. And next here you can see the alternative or extension flow, it is also called as loop. Then basic flow, simple line. Then returning alternative flow, that is there. Step 3 is there, then fork is there. Finally join is there. Parallel activities, see, after forking, here for forking, this is the fork, and at the end join is there. Parallel operations in step 4.1 and 4.2 we can show. And finally post condition, that is nothing but your stop is there. Next point is activity and action. Activities are nothing but the functions or operations performed by system. For example, login, process order, print order, place order. Actions can be smallest functional unit within an activity. Action represent a single atomic step within activity. For example, we login, that is the login activity, entering username, entering password can be action. Now see here, activity is given and action is also shown. Now we'll see next line, next layer, topic, that is the initial and final activity. Now see, this is initial and final activity. For both sign is same, but for initial activity, as it is initialized, control flow is to the next step, and from the control flow to the end, that control flow is different. The starting state before an activity takes place is depicted using the initial node. Now see the following figure. A black filled circle is used to show initial node of a system. For example, here is the initial node, that is the state of the system before application is open. Now next is the description. It says that if there are more than one initial node, a control token is placed in each initial node when the activity started. Initially multiple flows. If an initial node has more than one outgoing edge, only one of these edges will receive control. Now final activity node, see here, final activity, you can see this is your final activity. And what it says that a filled circle within a circle notation is used to represent the final activity node in an activity diagram. For example, a system, the flow or process ends in the final activity node, An activity diagram can have multiple final activity nodes. Final node represents a final or terminal state on an activity diagram. Final node is represented by a bull's eye. Next is your activity edge. Here the activity edge are used to connect activities which are in a flow. They are directed connections between two activities. There are two types of edges in an activity diagram: control flow, object flow. Now see, control flow, it shows or depicts the flow of control through activity. Now here field order, and then next activity is the ship order. So this is the control flow. And object flow, here you can see the object flow from one object to other, then again next. So create order, object in state, that is the order open, dispatch order, order dispatch. So using this, object flow in the activity diagram can be shown. Now next is your decision and merge points. Now see, decision node can be represented as follows. Here is the diamond where true or false, yes or no, present, absent. Likewise, decision has to be taken. Then this particular decision node is used. So guard X and guard Y. These are the two decisions made here. It routes the flow to one of the outgoing edges depending upon the conditions specified at the decision node. Guards are specified on the outgoing edges. Merge node can be represented by following notations. See, two incomings come to a particular diamond, it is also called as merge. So for merging also, this diamond is used. It brings together multiple alternative flows. All controls and data arriving at a merge node are immediately passed to the outgoing edge. With the good example, we see it. Now see, this is a good example of decision and merge node. So initial is here, then process mail diagram is this, get mail, and if mail is keyword or it's a junk, if keyword, then open mail, if it is a junk or gar condition, bin mail, then merge node, and finally your end. So this is the good use of decision and merge node. Next is your fork and join. Now fork node splits flows into multiple concurrent flows. Fork node models parallelism in the system. The activities which are executed in parallel can be represented with the help of fork node. After shows only one outgoing incoming edge and multiple outgoing edges. So here that example is shown. And join node synchronize multiple flows. It shows multiple incoming edges and a single outgoing edge. Now with the example we'll see it. Now see here fork and join. So again your product process is there, initial is there, design new product is there. When forking these parallel operations, market product and manufacture product we can see. Then joining is there, and finally sale product is there, and at the last your stop is there. Now here in the next, input and output pins also can be shown in the active diagram. Actions can have input and outputs through the pins. It holds input to action until the action starts and hold the outputs of action before the values moves downstream. The name of the pin is not restricted, generally recalls the type of objects or data that flow through the pin. So output pin you can see here, and input pin also you can see here. Next is your activity group and partitions. Partition divide the nodes and edges for identifying action that have some characteristics in common. They often correspond to organizational units in a business model. Partitions can be hierarchical and multidimensional. Activity partition may be shown using a swim lane notation with two usually parallel lines, either horizontal or vertical, and a name labeling the partition in a box at one end. Any activity node, that is action and edges placed between these lines, are considered to be contained within the partition. Now see, this is the diagram. You can see that they can be represented horizontally or vertically as shown in this particular figure. Now here is a partition using hierarchical, and here in the next partition using multi-dimensional hierarchical swim lane notation. Next is your constraint and action. Constraints can be attached to an action. Pre and post condition can be referred to an activity or to an action. UML intentionally does not specify when or whether pre-post conditions tested. UML also does not define what the runtime effect of a failed pre or post condition should be. This following diagram shows an action with local pre and post condition. See, you can see here pre and post condition. So it is showing this particular what constant is there, name is there, and then constraint. And here drink name, then dispense drink, and again drink. Here drink selected is low calorie, drink dispensed is low calories. Using this pre and post condition is shown. Now here I declare that your active diagram is completed. In the next lecture we will see our next diagram, that is state machine diagram. Thank you very much.